All right. So, good morning, everybody. We are going to be talking about Tropilaelaps mites today. Kind of an overview. Number one thing is that these mites are not in the United States yet. However, we anticipate that they could be here as soon as the next 3 years. And so we want to start getting folks aware of what they are, what they look like, and how to identify them. Before they do that, I think I handed out to most of you a copy of the U.S. Beekeeping Survey. If you need another copy, I will be glad to hand it to you. But what this survey is, it runs every April. It's been happening since 2007. So there's a long history of this. And we collect data from beekeepers across the US. And this data is used primarily to give us our overwintering loss numbers. So that's a question I get asked a lot when I go to different clubs and talk about bees, is how many colonies did we lose last winter? And there's a lot of data that we collect from this that is used for recommendations for better beekeeping. So if I didn't get a copy of this to you beforehand, I'll get a copy of it to you now. This image is absolutely like the creepiest thing ChatGPT has ever made for me, but it's going to haunt you if you don't fill out the survey. That's my like warning. So between the 2023 and 2024 survey year, in Kentucky, we only had 17 beekeepers that participated. So if you were one of those 17, thank you so much. But if you did not have the opportunity to participate last year, we would love to see your participation this year because our numbers are so small. We estimate that we have 5,000 beekeepers in the state. So when we only had 17 participating, that was less than 0.3% of all of our beekeepers. And if you know anything about data and statistics, 0.3% is not very representative of our entire bee population. So we know we can do better in 2025. And some of the good notes on this are when we have this information, it helps us make state level changes. So recommendations that I can give to you to be better beekeepers, helping with knowing what's going on regionally or nationally, if there's any big things that we're seeing. And then it also gives you access to the survey as well. So the survey results will get posted online later this year. You can go and look at the past year's surveys and kind of see what's going on. So they make this as accessible as possible. We hope that it's pretty short to complete. If 20% more participation happens in Kentucky this year, we will be eligible for a drawing that they're doing. It's a fun thing that Auburn has where if we're selected, they will come and do a presentation at our state meeting this fall. So we don't know yet if we'll be the selected state, but the more participation we have, the more likelihood that we'll get to go into that drawing. So let's go ahead and switch topics to Tropilaelaps mites and look at them a little more in depth and talk about this invasive species. It kind of connects with Auburn. Auburn runs this study. They also are one of the leading institutions in the US on Tropilaelaps mites. So if you have questions or you want to dig deeper, I would point you to them and their resources for more information after the talk. So Tropilaelaps is small. It's about 1/3 of the size of Varroa, but it's very closely related to Varroa mites. If we zoom in and take a little bit of a closer look at it, you can kind of see there's some hairs on its legs. Its legs are a little bit longer, and it's got more of this seed shape to it, very oblong. Tropilaelaps is how we pronounce it. It's a lot to get out of your mouth and a little bit of a tongue twister, so a lot of times we just call it tropy mites. The laelaps part is kind of hard to get untongue tangled, so tropy or Tropilaelaps is what we would call this mite. Here's some overview of its biology. You're going to notice that it's very similar in its life cycle to Varroa, but I'm going to point out some key differences. So it's an external feeding parasite. Just like Varroa, it feeds on the outside of our larva or pupa. However, unlike Varroa, we know that Tropilaelaps mites' mouth parts are not able to pierce the exoskeleton of adult insects, right? So the exoskeleton of larva and pupa is soft versus the harder, crunchier exoskeleton of the adults that's hardened. So it can only survive on adults for about 3 days before it needs to feed before it dies. So if there's no larva or pupa, it wouldn't be able to reproduce. We also know that the larvae are light, opaque in color, and then as they age, the adults are going to be more red-brown. So here's kind of a cell with a mother Tropilaelaps and all of her offspring. The female mites can also share brood cells. So typically Varroa will have one adult female per cell, and they'll be feeding on one larva. Sometimes in really infested colonies, we might see sharing of cells, but we know that Tropilaelaps mites, because they're smaller, can share a host. So we may see more females. And we also know that these mites reproduce about 25% faster than Varroa. So in areas of the world that have both Varroa and Tropi can outcompete the Varroa mites in those colonies and can cause bigger impacts than the Varroa mite. If we kind of look at its life cycle, it's important to note, right, it's going to lay its eggs. The adult's going to come into the cell. The female will lay her eggs. They will grow and mature. And it only has about a 6-day window from going from egg to adult. So if it's able to get into the cell really early, start its reproductive cycle, we may have a couple generations before that cell gets uncapped. Here's kind of how it looks as it goes through its life stages. These are pretty tiny, but the egg maturing as a larva up until it's an adult and it gets that darker sclerotized outside skin. So we have the adult female, the adult male. If we look at this picture of this larva with these Tropilaelaps mites on it, you'll also notice those little black dots, which is not normal for our larva. Those little black dots are feeding damage from how many Tropi were in that cell. And you can kind of see where that little arrow is at the top. That's one of those immature Tropi mites up there. So part of the impact that they have is that they can do this feeding damage. And when you're looking at the larva, they spread viruses to both the larva and the pupa. And then as that larva is maturing, if those bite marks happen in key areas like wing development, we're going to see things like deformed wings or pupa that die before they're able to emerge because they've had so much feeding damage. Here's a picture of our cell. Can you see the Tropi? It's right here. It's very small compared to the Varroa. You think Varroa is hard to see. Tropi is even harder. So I'm going to pull this up for us to look at. This is a website. It's called honeybeepests.org. It's managed by Apiary Inspectors of America, and it is a resource that is combining in all of the different extension publications, research articles on Tropilaelaps. So anything that's been recently published, you can come here and see any videos. I would really encourage you to look at Project Apis M. That's a nonprofit organization. They have created a series of videos that are a documentary style educational video on Tropilaelaps. It's on YouTube for free. It's very like PBS, Nova, nature documentary. So it's very, very well done with a lot of information of what we know right now. And then this is the video I'm coming down to. Look over in this area. This is where we're going to see that Tropi mite and watch its movement. So here it is right here. That bee just kind of stepped on it, but watch how it moves kind of down into the cell, and it's got a lot more hesitancy and kind of jerky movement as it's moving around the cell. So that is an indicator for us. Varroa mites tend to move pretty flat across cells. With the Tropi, they're much more jerky in that movement, or hesitant kind of. So if you're looking at a frame and you see mites or something crawling around that's got that jerky movement, that's going to be an indicator that you may have Tropilaelaps in your colony. So I'm going to take that down and we're going to keep going. It's fun to watch all those videos, but for sake of time today. Comparing its biology to the Varroa mite, Varroa, like I said, is about 3 times bigger than Tropi when we look at it. Varroa are more oval shaped, kind of going the long way with their head being on this top end, whereas Tropi have more of this oval shape going up the length of their body. comparing the two together, we've got the Varroa mite on the top of our bee and the Tropi mite kind of down here. Yeah, the poor bee is just overwhelmed. But when we're looking at it, right, we're probably not going to see Varroa very easily on our bees, but if you're comparing the two, the Tropi is even harder to see. Here's kind of some side-by-side comparison, and I'll say that I took this from a presentation that Jeff Williams from Auburn University did, so this is total credit to Jeff for coming up with these resources for us, but I really like how it's laid out. So when we compare Varroa and Tropi together, what we see is that they have similarities in that they are a parasitic mite. They reproduce alongside bee brood down in the cells, and they vector viruses. So those are their big similarities. However, they have some differences. So we noted that Tropilaelaps doesn't feed on the adults, but Varroa mites do. They require Varroa mites require a post-mating feeding phase before they can start laying eggs. So once the Varroa mite mates, it's not like she's going to be able to start reproducing, especially if she's in a cell. Remember, she mates in the cell with her brother, and then when the cell is uncapped, she goes into a new cell and starts laying eggs and feeding. But she has to have that post-mating feeding ability. So it's less likely to see multiple generations in one cell. Whereas with the Tropilaelaps, we don't have that post-mating feeding need. So there's no phase, there's no period of time in which the Tropi can't just start laying eggs. So when we say that it outcompetes the Varroa, this is one way that it does that. Another way that it does that is that its egg laying interval, so its ability to lay eggs, is much shorter. And you think 6 hours may not be that big of a difference, but when you start looking at this over a period of weeks or a period of days, those hours start to add up, which allow that Tropilaelaps reproduction rate to be so much higher. And then in Varroa, only about 50% of the females are reproductive. We have about 50% that are non-reproductive. In Tropi, 30% are non-reproductive, meaning that there is, help me do early morning math, 70% of the Tropilaelaps females that are reproductive. So again, they can outcompete Varroa in a variety of ways.
Amanda?
Yes?
The Varroa feed on the fat bodies, whereas Tropilaelaps feeds on the hemolymph, correct?
Correct.
Is that like the blood of the bee?
The hemolymph is the blood. There is some fats in it, but it's not stored the same way as fat bodies are. So there is a little bit of a difference on where it's feeding, but again, when we're thinking about feeding on adults, it would just be the Varroa on the adults. All right, so lookalikes, it's important to point out that there are some other mites that might look like Tropilaelaps. I would rather you call me out of caution to come help identify this instead of just being like, oh, there's some mites. What are they? So there's over 700 species of mites that could be associated with our bees. Most of them don't have an impact on our honeybee colonies. They're in low enough numbers that they don't really build up. On occasion, we might see something like this. So this is pollen mites that have inundated one of our native bumblebees. When the researchers first saw that, they were really concerned of like, what is this new mite that is like all over this bee? They sent it off to be sampled and they're like, oh, okay, it's pollen mites. This bee just accidentally landed on the wrong flower. All the mites jumped on board. It was kind of inundated. So we kind of see these one-offs on occasion, but if you do see something suspicious, I would much rather know that there's something out there than to not know. And we will keep kind of this in mind as we go through here. So Tropi is this one up on the top. Here's kind of a comparison of all of them together. Again, Tropi's the one down here on the bottom, but you can kind of see when it's all really tiny and small that there's a lot of potential for making the wrong identification. So happy to work with you on that if there's ever any question. Good to kind of do an overview of where Tropi came from. We get this question a lot. So Apis dorsata is the giant honeybee that is found in Southeast Asia, and it is different than our honeybees, the European honeybee, in that it has open colonies that hang from trees. So this means that there's a lot more accessibility for pests to be able to kind of access. And these open colonies allow for, if the tropy is here, to drop down on things below it. So if you've got trees and you've got bees interacting, not only can those adults potentially be spreading things, the honeybees could come up here and start stealing things and come in contact with those brood areas, or those tropy could drop down, are all different ways that we believe that they began to make that transition. So when we brought European honeybees to Southeast Asia, because they are a very effective pollinator, we can keep them in colonies, right? It's not very easy to keep a colony of these guys going because they're up in these trees and you can't really make them stay. In some areas, they also migrate at different times of the year. The migration is a great way for them to naturally control Tropilaelaps because they are leaving that area. They're going to have a brood break when they do migrate to somewhere else. However, our colonies don't get that advantage because they are being moved by us, they're being managed year-round by us, and those European honeybees don't have that migratory phase. So when they entered and transitioned over, we saw this species jump where the Tropilaelaps got into European honeybees, and then as we have moved those around, we have seen that movement expand. So they were originally found kind of in this area between Thailand and Vietnam. They have spread out since then and are now down in like Papua New Guinea, which is kind of scary because that's really close to Australia, which is a really big bee producing area. They're also moving towards Europe. We've had identifications in Uzbekistan and Georgia. Also, we've had identifications in Ukraine, which is really scary because there was a huge movement of Ukrainian queens to Canada, and there was a huge trade between Canada and Ukraine that was going on up until the fall of 2023 when we noticed that this could be an issue. So Canada is no longer importing those queens. There is a lot of importation rules on what we can and can't bring into the US. So we've stopped that. However, it's really hard to track its movement in Ukraine and Russia because of the war that's going on there right now. Not a lot of data is being shared on honeybees, so trying to track that is challenging. It is important to note that the World Health Organization has identified Tropilaelaps as a reportable disease of honeybees, so it's one that they are tracking at a global level, and we're trying to get as much information as we can because it is such a huge threat to the industry. All right, here's my fun thing. How many of these Tropilaelaps can you find on the card that I'm about to give you? So I have these cards, and I'll give you just a second to look at them. The little circle is an example of the actual size. Yep, this is an IPM sticky board. The little circle is the actual size that you would see them. The big circle. You can look at the whole card if you want to, but you can also just count inside the circle. They kind of just zoomed in the area because they wanted to blow it up a little bit. So this 2 times the actual size. Some people pull their cell phones out and use it as like a magnifying glass. Just to help you orient yourself on the card for a second, there is a Varroa mite right here, and there's a Tropilaelaps mite right here. So I'll give you a second to look at the card. For sake of time, we're not going to do too much with this. But anybody have any short guesses of how many Varroa versus Tropy you think are on here? Just initial. All right, so if you flip your card over, you can scan it. I'm going to actually show you the results here, but you can get more information from the back of the card. But here's what we got. All of these blue arrows are Tropilaelaps mites identified on this card. The 2 green arrows, right, those are going to be your Varroa, which are kind of our orienting. So hopefully what the little exercise shows you is that these are going to be really hard for us to identify in the field. Even with the sticky boards, you're probably going to need a magnifying glass or a microscope to be able to really see, or at least start training yourself to be able to see these. I've looked at them in person, and I've done a lot of microscope work going through entomology programs, and they are really hard to identify, especially when you have a sticky board that has all kinds of other debris on it. So it really does take some training to be able to identify what they look like. We hopefully...
Where was this board?
So this particular board was collected in Thailand. We do have boards that went through a freezing and quarantining process that are in the US, and we're hoping to do some regional trainings in the future that would have some of these real boards with us, but because there are 50 states and only a handful of boards, Auburn's the one that monitors those. So if you fill out the beekeeping survey and we get selected, maybe they'll bring some of the boards up here. It would be cool to see them in person. How could Tropy arrive to the United States? Most likely, we believe that it's going to be coming in through a port of entry, so an airport or a harbor, you know, a colony that is coming in accidentally on a shipping container, or through an airport by accident. We don't know that one of those areas would be the first detection. Honestly, with the amount of movement of our bee colonies, it could be anywhere in the country that it's first identified. It's possible that it could be present for some time because it's so small, and if you don't know what you're looking for, or have any awareness about this particular pest, you might not see it until it's already causing devastating problems for you. Therefore, having that vigilance and some of this early training on identification is going to give you a leg up, hopefully in the future, so that you can help with this identification step. Again, if you think you have it, we would rather know. We know that it's not you who brought it to the US, it just somehow accidentally has gotten into your colonies. So we would rather know that it's here so that we can start helping to address the problem than waiting until it's a widespread issue. So if you think you see something, please feel free to say something to me, call me, I'm happy to come out, and we'll talk about that in a minute. So monitoring is what we would encourage you to do, so those sticky boards. But here's some of the behaviors you might see change in your bees. So crawling honeybees and brood discarded at the entrance of the colony, so something's just not right. There's a lot of hygienic behavior that we would see. Any unexplained colony absconding or colony losses that we would have. If you can't figure out another reason, this might be it. Any irregular or poor brood patterns because of that hygienic behavior. Also, and I think this is probably one of our more key indicators, is having a lot of pupa that are not able to emerge, or that when the adult emerges, we have a lot of deformation issues because of all of that feeding that happened. So that's an indicator. And then it's also going to be in your colony increased symptoms of viruses, especially deformed wing virus, which the Tropilaelaps can spread. I would just point out what else can cause some of these symptoms. There's lots of our bee pests and diseases that can cause very similar symptoms in our bees. So just taking some time to study what we currently have in the US that could be causing these problems, so that if Tropy shows up, you can be tracking that there's a difference or a change in your colonies is important. Monitoring methods that are currently being used. We have powdered sugar and alcohol washes. These are really effective for Varroa. However, they are not effective for Tropy, primarily because, exactly, the Tropilaelaps mites are not on the adult bees. Therefore, we would maybe catch a few, but we would not be getting a good picture of the number in our colonies. The other two options that we have are examining of brood cells and sticky boards. So brood cells, if we open up and uncap brood, pull out some pupa, look inside those cells, look at what's on the pupa, we can have really high sensitivity. We'd see what was down in there. It would be yes or no, and then we could count them. But it's very time consuming. Most of us aren't going to have the time to pull a bunch of pupa out and do a monitoring process this way. Sticky boards are like the seconded most recommended way to track for Tropy. It's very sensitive, right? If the Tropy drop down, it's hard for them to get back out. It's also hard for them to move from place to place, so they're probably not going to crawl back up into the colony. So those sticky boards are a great way to track. However, if we're not changing them out frequently, they get really, really dirty. And as you saw from our example card, it's really hard to see through all of that debris for a lot of us, right? Unless we have those tools like a magnifying glass or a microscope to look at. What we've seen to be the most effective, and this is what we use with the Honeybee Health Survey currently, so I go around and survey beehives in Kentucky, and I use this method. It's called the bump test. We say that it has moderate sensitivity, so it's a pretty good indicator of testing for tropy, and it's pretty fast, although it has to be done during an inspection, right? You have to get into a brood frame. It's going to do a little bit of damage because we're going to hit that frame very hard against a white pan. It will probably dislodge some of the larvae and eggs that are on that frame, but the idea is that we are knocking any potential mites down onto that white surface so that if they were crawling around, we could see them. I collect my samples in alcohol, so I send that alcohol sample in to be checked. And so this is the most recommended right now. In the future, what we're looking at is doing something called eDNA or environmental DNA. This is where we would have a cotton swab as inspectors. We could come and we could swab things like the sticky boards, the brood frames, send that cotton swab in for DNA testing to kind of get a positive or negative on if tropy is present in the colony. The end hope is within the next 5 years or so, we would have an indicator kit that you could purchase, right? So just like we had the EFB and AFB test kits, there are folks that are working on getting a test kit prepared for tropy so that you could do a field test yourself to detect. But that's still a little ways away for us. There are different management practices that we can use. I usually don't encourage folks to read scientific papers because sometimes it's a lot of information. If that's something you're interested in, go for it, but it's really data heavy. This, however, is a really great article that Jeff Williams and his team from Auburn and the team from Thailand worked together to put out that has all of the current management strategies for Tropilaelaps mites, including chemical and non-chemical and integrated pest management techniques and what is effective. So this is a great article. It's very accessible to read. We're going to summarize it. First, the chemical management that we have, so synthetic chemicals that have been shown in other countries to be effective are things like Apistan, Checkmite, and Vavorol. These products are usually pretty hard on our bees. We do see some colony losses when we use them. There also are places that are using potassium nitrate and amitraz combined and making it a fumigant. Remember that fumigants are very dangerous to use, so we need to have specialized equipment for application. And then precipitated sulfur is being used in some areas as well. However, I'm going to point to this top line here. Currently in the United States, there are no products that are specifically registered for managing Tropilaelaps mites, meaning that if you were to get tropy, you could not use your Varroa products or other products that online or that have been affected outside of the United States. Until the EPA releases a product that has labeling for Tropilaelaps, we would not be allowed to use any of these products for control or management of tropy. We'll talk about that in just a second too. Some of the organic and essential oil products that we have seen that are effective are formic acid, thymol, and a combination of thymol and oxalic acid have had the highest effectiveness against tropy, more so than some of those other products, as well as thymol mixed with essential oils, again used as a smoke or a fumigant, highlighting that smokes and fumigants are very difficult to use and you need specialized equipment for them. But in other areas of the world, this has shown to be effective. However, any chemical use is going to have some risks and challenges associated with it. One being that you have to have at least an 8-week break before you would put your honey supers on. So if they come during honey season, you would either have to not be collecting honey or you would have to have that break period. Also, you may end up with mites that are resistant to some of these products. Risk of translocation, we know things like checkmite, which is no longer available in the United States, has a high effective ingredient that's a carcinogen that also has long-lasting impacts in our hives. So it can be moved from the honey to the wax to the larva to the pollen. Everything within the hive could be contaminated by this product long-term, and that could have long-term impacts on our bees. And then there is also just the risk to the bee health, because treating them with a chemical product, even if it's targeted at mites, is going to have some side effects, because bees and mites are invertebrates, right, that are going to have similar impacts from those chemical products.
Is that Cumulphos, Amanda?
Cumulphos, yeah. All right, so just a note on pesticide use. I'm going to put these up here. I'll give you a summary of it. So the USDA and EPA want to remind the beekeeping community that existing registered options for varroa mite could potentially be effective options for Tropilaelaps. However, we have to pay attention to the labeling. So if the label is not specific to a mite, if the label says only can be used to control varroa mites in a bee colony, then you would not be allowed to use it on Tropilaelaps. If it's the label language said available or applicable for use on mites impacting bee colonies because they used mites and not a specific mite, then it would be allowed to be used. And then the other thing is, any product that we use also has to have co-registration with being allowed in a bee colony. So there are other miticides used in agriculture or in pest management that you might see advertised, but if it's not legally allowed to be used in a bee colony, we could get in trouble if we did use it. Although nothing is registered right now, should Tropilaelaps be detected, there is a process to work with USDA for exemptions or EPA for exemptions to use a product temporarily while that label would be changed. One of the reasons that we are not seeing a run to change all of our current labels is that it costs thousands and thousands of dollars to register a product with EPA and to change the labeling. So a lot of the companies are not interested in going through that process until that pest is here. So we do have a way that we would be able to react to it if it got here and be able to get access to some of these products. I've talked with our state insecticide inspectors and the folks that would be allowing the registration process for Kentucky, and their current guidance to me to talk to you guys is to say that we would follow whatever the federal guidelines were. So if the federal folks said that we were allowed to use specific products or given us an exemption for specific products, Kentucky would be okay with that. There's some states that have much stricter pesticide laws than we do, and those would be states that might not allow those exemptions. But Kentucky is planning to follow whatever the federal recommendation is if we were to have Tropilaelaps detected in the state. There are other apiculture practices, so integrated pest management techniques that we can use to help suppress Tropilaelaps in colonies, and these tend to actually be more effective than the chemical management. So using multiple forms of these management tools is going to be our best way to use suppression. And currently, thus far, the research that we're seeing from these other countries is that if we use a combination of formic acid and brood breaks, that's going to be the most effective way to suppress tropy, because if you don't have brood, tropy can't reproduce. So having that brood break is the most effective. And then if you do have brood, using something like formic is going to help with suppressing the numbers within the colony. Other things that we can do are going to be forcing those brood breaks, splitting colonies, right? Similar things that we do to help suppress varroa mites. Screened bottom boards can be effective, again, because tropy drops down, can't get back up. It may also require us to reduce our colony size or change how we manage bees in the United States. And this is a bigger topic of conversation. But in Southeast Asia, a lot of times their honeybee management in their hives is single boxes designed a little bit differently versus how we use our Langstroth boxes that are so large and we have these large colonies, we would probably transition, if this became a huge problem in the US, to these smaller colony sizes to help with this management. Also, having a winter brood break, again, that's a naturally occurring break in when we would have larvae and pupa present in a colony. Auburn University, it's all tied together, is also helping with a really cool study. They're working with research institutions across the country to monitor winter brood breaks. So the data and the research that we have on when brood breaks happen in the United States comes from like 100 years ago. It's not recently been looked into. So especially with climate change impacting weather cycles, how harsh winters are or not can impact whether or not the queen stops laying eggs. And we just have not had anyone looking into, do we actually see a brood break in the winter time, like we anticipate, right? Like what we think happens. So their research project is looking at this. Based on some of their early data, you can kind of see they checked colonies in the southern United States and they did not receive a brood break. So this naturally occurring break would not be happening here. Perfect. And then some of these northern areas did see brood breaks. So Kentucky is maybe still in that zone where we would have some of that brood break, which means we maybe would be a little bit more, have that advantage if trophy showed up, that we would have brood breaks that could help suppress populations. Because of our time, there's lots of cool things we could talk about, but I do want to skip around a little bit so that we can kind of hit some of the bigger things as we go through. So let me find where we are. So brood breaks would be important, but let me skip down to, if trophy shows up, what do we do? So at the federal level right now, there are bans on importing live bees from other places, especially places that would have Tropilaelaps. But if you're in your colonies and you think that you see trophy, the first step you should do is take observations. If you can, take photos. If you can collect some of them and put them in alcohol or vodka, either one. That way we would have something to look at and identify. It could be one of those other mites. It could be Tropilaelaps. Then what you would do is you would call your state inspector. In this case, it's me. Hi. I would come out, we would go through your colonies together, do some of those bump tests, see if we could collect some specimens. Those specimens would have to go to the USDA to be formally identified. We have specialists in Beltsville, Maryland, who are leading the identification process. Tropilaelaps concerns kind of get expedited through. If any of you have ever sent something to the USDA, sometimes it takes a while for those samples to get processed. But trophy is one that we would hear back very quickly about. So that is something that we want to keep an eye on. And that would be the reporting process if we did see trophy show up in the US. I'm going to skip down through some of these just because I want to make sure that we have time to talk. But here are some of the current resources for you guys to look at and to consider. So honeybeepests.org has an entire resource dedicated to Tropilaelaps mites, where they are taking all of the extension guides that have been written, publications from USDA. It's just a one-stop shop for all of the science-based Tropilaelaps data. They are also currently working on creating this database for our other important pests like yellow-legged hornet and varroa mites and European foul brood. So as this website evolves, it's all kind of been done on a volunteer basis, so it's a little bit slow getting there, but it is a great resource to have, and they're really on top of trophy. So trophy is going to be the most dedicated or have the most information. These other organizations are all working together to try and make sure that we have knowledge and understanding of what is going on and that we have the most up-to-date information. And then, like I mentioned, I would really encourage you to take some time to watch the Project APISM videos. These videos are going to have a very documentary style. What could the long-term impacts be? What is the best management practices right now?
Amanda,
yes.
I know Florida and Georgia have the yellow-legged hornet. Have we spotted it in Kentucky yet?
We have not. So Florida, Georgia, and South Carolina added. Yep. So
is it only a matter of time, in your opinion?
We'll see how effective their eradication methods are. At the moment, it's still probably going to be a few years before yellow-legged hornet would get here, but it does have the potential. And we're talking about how to implement early monitoring.
They handle cold climates. Would they handle our winters? They would.
Yeah. Yeah. So that's a whole nother talk that I will save for a future. But for anybody who's interested and doesn't already know, I have a monthly webinar that I do that's kind of just a summary of what's happening in Kentucky, what we see, if there's any new resources. I do a Q&A if there's any questions. This month in April, we'll probably spend a long time talking about US beekeeping survey. We may just go through it question by question to get as many people to participate as possible. So that may be what we do on Tuesday. Haven't quite decided, but it's the 4th Tuesday of every month. I record them if you're not able to watch it live. So if you're interested in getting onto my email list for that and getting information, that's where this QR code takes you. If you absolutely hate QR codes and don't want to do anything with them, you can also email me and I can send you the link to be able to sign up for that. You can also call me, text me, email me if you need to get a hold of me. I'm happy to help answer questions on things other than Tropy 2. So if there's other stuff going on, I am happy to help. So, and if I didn't get a copy of the US Beekeeping Survey to you, I'm coming with them now.